So vibration and waves, and we'll do an exercise. A sinusoidal vibrator of frequency f equal 8 Hz emits at a point S of the surface of a liquid circular transverse waves. So we have transverse waves propagating at speed of v equal 28 centimeter per second, where the frequency is 8 Hz. First one. Compare the vibration produced at S to those produced at a point P 14 centimeter away from S. So this question here is the same question as determine the vibratory state of the point P with respect to the source S. In order to find the vibratory state, so we have to do the distance between P and S and over lambda. But in order to find the answer, we have to find lambda first. So lambda is equal to V over the frequency, which is equals to 28 over 8. And here we can get the wavelength, and we can leave it in a centimeter and then do the answer. So it will be equal to 3.5 centimeter. So in this case, we'll have the distance between P and S, which is equal to 14 centimeter over 3.5 centimeters. So لازم يكون عندنا same unit here, which is equal in this case to 4. We notice here that the answer is an integer. And since it's an integer, this means that the distance is equal to 4 lambda, which means that it's an even number of lambda. So we say that P and S, this means P and S vibrate in phase with respect to each other. Now let's do part B. So we want the vibratory state of a point Q, which is 33.25 centimeter away from S. So we'll do now the distance between Q and S over the wavelength, which is equal to 33.25 over 3.5. And the answer will be 5 by 3.5, so it's equal to 9.5. We notice here that we have a decimal number, and it's a decimal 0.5. So it means we have here a half lambda, which means that Q and S vibrate in antiphase or in opposition of phase. Now in the part C of point M, which is 39.5 centimeter from S, so we'll do the same thing, distance between M and the source, over the lambda, which is equal to 39.5 over 3.5, and we'll get as answer 11.28. So it's a decimal, but it's not 0.5 and it's not an integer. Then in this case, we can say that M and S are or vibrate are neither in phase nor in antiphase. Now we have to pay attention that this lambda now is a given. So we have lambda equal 3.5 centimeter. We can use it now. Part 2, specify if the point P and Q, so we have lambda equal 3.5 centimeter. Specify if the point P and Q vibrate in phase or antiphase with respect to each other. Now, if we notice in the part 1, P is vibrating in phase with the source, while Q is vibrating in antiphase with the source. So, which means that P and Q are vibrating with respect to each other in antiphase. We can either do the calculation or we can trace, for example, a figure. If I want, for example, to trace a figure like the shape of the figure, so I can say, for example, if S is at this point and we had P is in phase with the source, so let's suppose that P is here. Actually, we have 4, so it will be like 1, 2, 3, and 4. So let's suppose that P is here. So S and P are in phase. While if I notice Q, we have Q 9.5. So it will be 1, 2, 3, 4, 5, 6, 7, 8, and 9. And this is 0.5. So which means that Q is here. So if I want to draw the figure, this is the shape of the figure. So we notice that P and Q are in antiphase with respect to each other. So P and Q are in antiphase with respect to each other. Now, if I want to do it by calculation, we can also do it by calculation by finding the distance between P and Q over lambda, and supposing that P and Q are from the same side of S. So in order to find the distance PQ, we can say that it's equal to the distance to QS minus the distance PS, which is equal, we had the distances 33.25 minus 14. So 33.25 minus 14. So we'll get as answer 19.25. And then we'll do it again here. So it's 19.25 over 3.5, which will be equals to 5.5. So we notice it's a decimal 0.5, the answer. So it's a half lambda, which means that P and Q vibrate in antiphase. So we can do it either in the form of tracing or an explaining, either in the form of calculation. So now part 3. Give the expressions of the distance of points in phase. In order to find, when we say expression, this means we don't have to do any calculation. So when we have 2 points in phase, we know that the distance between the 2 points is equal to k integer multiplied by lambda, which means that it's equal, if I want to put the lambda, it's equal to 3.5 k. Now, while in part 4, give the expressions of the distance of antiphase points. So in antiphase, it will be equal to 2k plus 1 and lambda over 2. So also if I want to put lambda, so I get as answer is 0.5, which is over 2. So 1.75, so I get 1.75 multiplied by 2k plus 1. Now, let's continue. Determine the distance between the second antiphase point and the third point in phase. So part 5. In order to find the distance of the second point in antiphase, so I'm talking in antiphase, which means that the distance is equal to 2k plus 1 lambda over 2. When I say second in the case of antiphase, this means this corresponds to k equals to 1. Since we know that the first is k equal to 0. So then this means that the distance is equal to the first one, so I'll name it here, for example, d1. So it's equal to 2 multiplied by 1 and the plus 1 multiplied by lambda over 2, which is equal to 3.5 over 2. And then we'll get as answer, so times 3, which is equal to 5.25 centimeter. Now, let's find the distance of the third point in antiphase. The distance here, we find the distance with respect to the source. So let's find the distance of the third point in phase. So when I'm talking in phase, which means that d2 is equal to k multiplied by lambda. In the case of phase, when I say third, this means this corresponds to k equal to 3, since the first k is equal to 1. So we'll obtain here 3 multiplied by 3.5, which is equal to 10.5 centimeter. Now, in order to find the distance between these two, so we can say the distance between the second and the third point in phase is equals to d2 minus d1, which means it's equal to 10.5 minus 5.25, and then we can get the answer. So it's 10.5 minus 5.25, and then it's equal to 5.25 centimeter. Now, part 6. The frequency of the vibrator is changed to F prime. So now we change the frequency. Determine F prime. So we have to find F prime is equal to how much? If the distance between the third antiphase and the fifth point in phase is 15 centimeter. Now we have to pay attention to something. So in order to think about it, we always start by the unknown. I have to find F prime. So let's see. We know that the rule بتقلنا إنه F prime equal, we know V equal lambda times F. So F prime is equal to V over, I put it V prime over lambda prime. Now, but we have a remark here. We know that if I don't change the medium, which we didn't change the medium here, then this means the speed will remain constant. So I can say that V is equal to V prime, and we already have the speed in the first exercise, and the exercise is equal to 28 centimeter per second. So I can put here 28 centimeter per second. Now, in order to find f prime, we still have to find lambda prime. Okay, so how to find lambda prime? لازم يكون عاطيني شي hint. Let's see here. The distance between the third in antiphase and the fifth in phase is 15 centimeter. So let's do it here. The distance of, I'll take now the third, so equals to 2k plus 1 lambda over 2, since I'm talking in antiphase. And since I'm saying third, then this means that k is equals to 2. So I'll get 4 plus 1 and multiplied by lambda over 2. And this here in this case will be lambda prime. It's the new wavelength. So we can continue, which is equal to 5 over 2. So it's 2.5 lambda prime. And this is the distance of the third point in antiphase. So this is the point 1. Now the second hint, we have the distance of the fifth in phase. When I say in phase, this means k lambda, and it's a prime, while the k is equal to 5 here. So I get here 5 lambda prime. Now, as given, we have that the distance between them is 15 centimeter. So this means that implies the distance between, which is the distance of the fifth, minus the distance of the third, is equal to 15 centimeter. So I can now substitute here, and I can get as answer 5 lambda prime. So it's 5 lambda prime here, minus 2.5 lambda prime is equal to 15 centimeter, which means that 2.5 lambda prime is equals to 15 centimeter, and then I can get lambda prime is equal to 15 over 2.5, which is equal to 6 centimeter. وهيك بنكون طلعنا اللامدا prime. Now, لما طلعنا lambda prime, then I can calculate the frequency. So the question was the frequency first. So the frequency is equal to, I can take the same speed. So here I put, since V does not depend on the source, but on the medium. So it depends on the medium. So f prime is equal to 28 over lambda prime, which is equals to 6. Then I can get the answer, and I have f prime is equal to 4.66 hertz.